Welcome back to the Datarekha audio guide. I'm Diya.
And I'm Arjun. Here's a fact that surprises everyone the first time. When you serve a large language model, the thing you run out of isn't compute, it's memory. And one little cache is the reason why.
That's backwards from how I think about AI. These models do trillions of multiplications. How is memory the bottleneck and not the math?
Let's build up to it. Generation is a loop. The model writes one token, sticks it on the end, and runs again to get the next one. Now, naively, every time it adds a token, it would reread the entire sequence so far and recompute the attention for every previous word. From scratch, every single step.
And that gets quadratic fast. 1,000 token answer means the last step reaches 1,000 tokens. But if the answer never changes, why recompute any of it?
You shouldn't, and that's the key. Almost all of it is pure waste. The attention math for word 5 is identical whether you're on step 6 or step 600. The earlier words don't change, so neither does their result.
So the fix is just save it once and reuse it? Stash each word's result the first time you compute it?
That's the whole idea. For each token, attention produces two things. Call them a key and a value. We store them. Then on the next step, the model only processes the one new token, and it looks up the cached keys and values for everything before it. That stash is the KV cache. It turns reprocess everything into process one token.
Huge speed up. So where's the catch? Because there's always a catch.
The catch is that the cache has to live in GPU memory for the entire request. And it's big. It grows with how many users you're serving, times how long each conversation is, times the number of layers and attention heads in the model. For a long context, that cache can dwarf the model's own weights.
Oh, so that's your memory bottleneck. The GPU isn't full of model, it's full of everyone's cached conversation.
That's it exactly. GPU memory, not raw arithmetic, is what caps how many requests you can serve at once. Which means how cleverly you manage that memory is basically the entire game of serving.
Okay, so how do you manage it well? Because it's big and there's lots of it sounds like a packing problem.
It is a packing problem. And the naive way is terrible. The simple approach reserves the maximum possible length for every request upfront, as one solid contiguous block. So if a user might write 2,000 tokens, you book room for 2,000, even if they actually stop at 40.
So the memory is mostly empty reservations, like booking a 100-seat banquet hall for every dinner reservation in case a big party shows up.
Perfect analogy. The pool fills up with mostly empty bookings, and only a handful of requests fit. The fix is called page detention, the idea behind VLLM, and it borrows straight from how an operating system handles memory. Instead of one giant block, you chop the cache into small fixed-size pages and hand them out on demand, only as each conversation actually grows.
So nobody books the banquet hall. You give each table exactly the seats it needs as more guests arrive.
Right. And the waste basically vanishes. That alone let achievable batch sizes, and therefore throughput, jump several times over with almost no fragmentation. But there's a second half to the win, and it's about scheduling, not memory.
Let me guess. Even if you pack memory perfectly, you can still waste the GPU waiting on the slowest request in a batch.
You've just described static batching exactly. It groups requests, runs them together, and can't let a new one in until the whole batch finishes. So a quick request that's done in 2 seconds just sits there, idle, waiting for the one that takes 30. The GPU twiddles its thumbs.
And the fix is to not wait. To swap in new work the instant a slot opens.
That's continuous batching. It schedules at the level of a single token step. The moment any sequence finishes, it frees its pages, and a waiting request slides into that capacity, mid-flight. No waiting for the batch to drain. The GPU essentially never idles.
So this is the real answer to why does everyone tell me to just use VLLM? It's these two things together.
That's exactly what it buys you. Page detention for the memory, continuous batching for the scheduling, Together, they lift serving throughput by something like 10 to 20 plus times over a naive loop at the same latency, and the tricks built on top, interleaving prompt processing with generation or routing requests that share a prompt prefix to the same worker, so the cache gets reused. All stand on this same foundation.
So the one sentence to walk away with:
The KV cache is why serving an LLM is a memory problem, not a math problem. And packing that memory well and never letting the GPU wait is most of what fast, cheap serving actually is.
memory is the ball game. That's the Datarekha audio guide. See you in the next one.